All right, this is a new recording. Don't mind my old one right there. I realized that I didn't show how what root motion was, so we're redoing this now. Okay, so just like the last one, here's my test level. I got a little platform to walk up on, a little field of cylinders to go through, and then just some spheres that you can walk around. And that's about that right there. I left my character at 0, 0. I know I built stuff around him, but whatever. So there's the test scene. Um, and now after I did the test scene, I'm just gonna go down that. So character uses root motion. So if I click on my character in here and we go over to his animator, we see that root motion is applied. And basically, what root motion does is it keeps your character model and your game object, like the two separate thing. Usually, there's two separate things there: the animations and stuff, and then like your character model. The animations go off. Your character to the game is still in the same spot because the animation isn't the same as you actually moving. Well, this makes it the same. It makes sure that your game object is where the animations are, no matter what. So if I were to run around in here, my character and my game object stay together, like his model, his mesh, whatever you want to call it. His position is actually where he is. I wish I had like a well, I have a sprint. I wish I had like an actual animation, like some of those flashy attack animations where they do a bunch of jumps and stuff, but I don't. So, uh, my player pawn right here that I have highlighted in the scene view, he is stuck. He's using root animations, and you know what? Let's just go to the animator really quick. This is the blend tree. Okay, I have it organized as sprint, run, walk, sprint, run, walk, and it has a lot. There's a lot. Okay, so it starts with idle, but um, I have a lot going on here. I thought I did a really good job with this. I'm imagining when I did the compute positions, it might have done something weird because there are. I showed it in the other video, but I'm going to take it down. So here it is again. There is some weird movements, as you can see, with my guy. Um, I'll go in and see what that is. It could be because there's no uh, rotation speed. Like he doesn't have a rotation speed. He instantly snaps to the spot the mouse is looking at. It could be, see that? Yeah. It could be because of that. I don't know. He had some weird stuff going on prior. And it really, I mean, I don't know who runs around like this in a game anyway. But if you had like a bunch of enemies charging you in this top down shooter and let's say it was just a bullet hell, this would be really annoying to the player. You'd be like, why like I'm sitting still. Okay, when he sits still, it's better. But so maybe some of my animations weren't zeroed out all the way correctly, um, which I'm not gonna go through all of these right here and look at it anyway. So there's the root motion. So the parameters that I'm sending to the animator. Let me just get over to my scripts folder. Actually, I have this up. I don't really need to do that. The parameters that I'm sending to my animator are basically, we labeled them in class as right and forward, but it's a input.getAxis. I'm getting the horizontal and the vertical axis, axi. I don't know. I'm getting those. I'm sending them into this function called move that's on my regular pawn, and we're just going through with that. We get the horizontal axis, set that as our x value in this new vector. We get the vertical axis, but we actually set it as the z so that we're not walking up into space, and we make sure that the y stays 0 so that's not happening, or down into the void or whatever. Um, so we're using input.getAxis to get these values, um, but what we're actually sending here is the same thing. We're setting the float to the forward to the to the vertical axis, and this is the horizontal axis. And we're also sending in this float value of our move directions. And that is how the animator is getting this data, well, in times the speed. But that's how the animator is getting this data so that it knows which animation to play, is these two set floats right here. So this is, so obviously right here forward, saying you're going to set this with this times that. So that's kind of how that goes. This will go and tell this to, let me see if I can keep this in here and show it. That's how we get, see, that's how we get those movements. And then you can see if I hit shift, the numbers jump up. And I might need to play with that 1.5 a bit to make sure that I'm always getting the sprint animation, because you don't ever want to sprint and then, you know, not have the sprint animation go off. That would just feel weird to the player. But anyway, that was my character in world space. Let me show the world space. It's this inverse. I think I'm going to knock out two birds with one stone here. Um, sort of. I didn't use vector 3 move towards. Yeah, here it is, Vince. It's not two birds. It's the same one. So this inverse transform direction, all it does is it takes our local space that we were in before, kind of like tank movements where you hold W and you go forward all the time. Like it's just your forward vector. It's like the asteroids game we made. And asteroids are always, whenever you hit W, we were always going wherever the ship's nose was facing. And that's because that feels right in this style of game. But here it does not. I mean, I think there's some top-down shooters that might do that. I would hate it. I'm far too used to Gauntlet. But this, what we, ooh, that was awkward. I'm gonna have to figure that out really bad. Anyway, so we're in world space now always. I'm holding D right now. No matter which direction I face, this inverse transform direction is gonna make sure that it takes in my move direction, and it finds out which, like, it translates that from local space to world space for us. Which, you know, maybe that's why I think I'm getting these weird things here because of something in the animator, not because of anything else. I mean, this is fun running around and sprinting. Stop. Okay, so that's basically how that works. This function figures it out for us. We don't have to do what we did in GPE104, where we translated the world space on our own. Um, I would do it on my own if it saves me more memory, but for now I have never used this before, so might as well just stick with it. And I might as well jump ahead and just say my sprint function since it's so easy and it's right here. We're looking at it. The only thing the sprint function is this variable. It's a float. It's a private float actually called sprint boost. Um, and I might change it to public later if the pickups need it. Like say I give you like a speed boost or something. I'm not sure. But for now it's private. I did a serialized field just cause, but just in case I want to change it, or a designer wants to change it, even though I'm the designer, so whatever. But basically it's, I just encapsulated the original this with an if statement. I added that onto the, I copied it and then added that onto the end of it. I multiplied it by 1.5, our speed boost, and then in the else part I just put the original one, because if they're not holding left shift or right shift, and I just do both shifts just to, I don't think anybody uses right shift, but just in case somebody somehow has a mouse on their left hand and they're using, I mean, you couldn't use WASD at that point, but whatever. Um, there you go. So, and all it is a private variable, and you just multiply it. You want to multiply it after the inverse transform direction. Sorry, that's a mouthful. Because if you put it inside the parentheses right here, like sprint boost, you're going to get some weird, it's not going to be accurate data. You want to get that number and then multiply it by this number. You don't want to multiply that number and then do the whole thing. I didn't try it out, so I don't exactly know if it would mess everything up, but I feel like that's not how you do it. So, all right. So now let's get out of our animator, and as you can see, I got this line being drawn where my ray cast is. I was gonna take it out, but we're gonna be continuing working on this project, and I'm just gonna turn it in, and this helps with my description. So what we're doing right there is, if I can zoom out, we're raycasting from the screen, which is the main camera, down to this plane. And to be honest with you, the plane is not actually the plane that the character is walking on. We have this invisible plane here that is at, you know, the origin point of this whole thing. It's at 000, and it's up one. You know, it might start at one. To be honest with you, I'm not 100% on this, but I'm pretty sure this puts it at 000, and I'm 100%, or I'm 100% sure this puts it at 000. But as for this, I think it sets it. I think where it would actually sit at is 00.1 or 010 or something. So I make this ground plane that's not actually a physical plane, and then I make this number that's gonna hold, like, we used to call it distance. My brain called it ray length for some reason here, because it's the length of the raycast. But now that I read the shell, distance might be better. But I'm already recording, so we're just gonna leave that as it is. And then we make this if statement right here that says if ground plane dot raycast. If our camera ray goes out and it hits, you know, the ground plane, what are we gonna do? So when this raycast, this blue line right here goes out and it returns true from hitting, you know, anything this plane, from hitting this plane, this is what we're gonna do. So when we get that true value, which as you can see we're gonna get that, um, this is what we do. We create a new vector 3 called point to look, which is the point we're going to look at. Um, and then we make it that point at the intersection, wherever they cross, wherever that raycast collides with that ground plane. That's where that point is that we want to look at. And this is happening every update frame. So it's happening so fast that our brains can't see it. Um, so we make that a point, right where it intersects. This debug is obviously just my line so that I could see what I was doing. And then I went really cheap here to get this done on time because it's now 8:46 and I've been at this since 8 in the morning. So we're on the 12-hour mark. Where this transform.look, all it does is it makes us look at this new vector 3 that I make, which consists of our point to look x, um, our point to look z, which is important here because we've been using our y as our z on our character. Um, you know, we've been using that, but here it's actually the y. If you have the y not locked down to something 0, like this is just our own y-axis. But when I first put it in there, my character was like flipping around, and even though his rotations are frozen because of the way this code works, he was still rotating on his y-axis trying to look at this point. And I said, no, like I don't want you to do that. So I made it this transform position dot y. So it's our own transform on the Y, so he's not looking up or down, he just keeps looking forward like you do in these kinds of games. And I made the point to look at Z and X a thing because, I mean, in a top down, you really are just using, in a 3D top down, you really are just using Z's and X's. Sometimes there's jumping in these games, but not always. So that's what I did there. I really did want to give it like a rotation speed, so I wasn't just instantly snapping here, but I needed to get this done. Sweet. So in both videos, my mic died for some reason. So we're gonna get this done quick before it dies again. So, um, I got my camera code, which is actually from my GPE104 final, where we just get the offset by, getting our position and our camera's position and our target's position, and minusing them from each other. And then to kind of get where we need to go, you're going to add the target position to the offset so that it follows where you want it to follow from behind. Which it's supposed to give like this trailing thing, but actually, if I remember correctly, I actually need to click on my main camera. It's the player pod. We're good. We're good. I don't public transform target. I didn't set it anywhere. I guess I must have dragged it in there. And didn't remember. Anyway, so we take that, we get a new vector 3 called target cam position, target cam boss, and we add the offset and our target's position to it, and that's how we follow me around, or your character around. And this one is the transform dot position of the camera, and what you do is you just lerp it here. And I actually had to look this up. I did not learn it naturally in this class or anything. So what it does is it interpolates between its own position, your target position, and then it's gonna add this smoothing float times time dot delta time to kind of make it super smooth. Um, which it does, makes it nice and smooth. Um, and as I walk around here, which I already walked around and showed you, but I'll just do it again. You can see the camera follows kind of behind. I have mine at a 75-degree angle. I kind of like that better, but it was just because the white was so offensive being at like a directly above that I couldn't see anything. So I changed it to 75 degrees because it was really hurting my face like this. Just looking at white like that all day. Couldn't see shadows. So I changed it to 75 degrees. Um, so that is my camera smoothing, the tracking of it. Let me show you my rigid body. So we got a rigid body. It's using gravity. It's got a massive 80. I froze the rotations on it, so we're not flopping around everywhere. You can see my capsule collider on my character. I'm not going through things except for when some weird stuff happens like that, I guess. Um, but as you can see, I can't just pass through any object. I mean, of course, all of these have colliders on them too, but we're not passing through things. I'm really gonna have to fix that in really bad. I'll see what that is. I have a feeling my walk backwards. Oh, I think it's in the switch. I think my transitions between these aren't smooth. Anyway, there's my colliders. They're really cool. That's what they do. Wrong thing. And now I showed you my scene right in the beginning. Um, I have code with comments, and I did my sprint function already, which I think I described it. I'm sorry, I just did this video twice in a row, so I'm not really sure if I did. It's just this if statement. I think I described that where we just yeah, I did. I did. I'll watch it again. Anyway, I hope the rest of your day is good. It's great to be in this class again, and I will try to see you the next class period. I'm gonna sneak it while I'm at work because they told me I'm not allowed to do class at work anymore, but I'm doing it. All right, you have a good day, Professor.